occupied Belgium September 1943 on a remote Luftwaffe airfield. Just after 1,500 hours, Hauptmann Klaus Richter, chief technical officer of Jägerschwader 27, received a piece of news that should have been a triumph. American P-47 Thunderbolt had been forced down, its pilot captured, and the aircraft itself was largely intact. This was intelligence gold. For months, German pilots had been encountering this massive American fighter, reporting capabilities that seemed impossible. Now, German engineers would finally have a chance to examine one up close. When Richter saw the P-47 on the tarmac, his initial reaction was the same as every pilot's. It was grotesque and obscenely fat and ungainly flying milk bottle. But as he began his methodical examination of the enemy machine, the engineer who believed in numbers was about to uncover a devastating truth. The P-47 wasn't grotesque. It was a prophecy, and its components were mathematical proof that Germany had already lost a war its leaders didn't even know they were fighting. Richter was not a combat pilot. He was an aeronautical engineer who had worked for Heinkel before the war. His job was to understand enemy aircraft, identify weaknesses, and recommend tactical countermeasures. When he arrived at the airfield and saw the P-47 for the first time, his initial reaction was the same as every German pilot's. This thing was grotesque, obscenely fat, and ungainly. The fuselage was massive, built around an enormous radial engine. The aircraft weighed nearly 8 tons, fully loaded. For comparison, the Focke-Wulf FW-190, Germany's frontline fighter, weighed about 4 tons. German pilots had nicknamed it the Fliegen Milchflash, the flying milk bottle. Looking at it sitting on the top Rimac, Richter understood why it looked like it had no business being in the air. But Richter was a scientist. He didn't care what it looked like. He cared what it could do. And as he began his examination, what he found would shake him to his core. Richter started with the heart of the machine, the Pratt & Whitney, our 2800 double Wasp engine. When his team removed the cowling, they stood in silence for a long moment. The engine was enormous, 18 cylinders arranged in 2 rows of 9, creating a radial configuration that explained the P-47's bulky appearance. But size alone wasn't what stunned Richter. It was the quality, the precision, the engineering sophistication. Every component was machined to tolerances that German factories were struggling to maintain. The cylinders were uniform, perfectly balanced. The crankshaft was a masterpiece of metallurgy. Richter pulled out his notebook and began calculating based on the displacement and design. This engine was producing at least 2,000 horsepower, possibly more, with the turbo supercharger system he could see integrated into the fuselage. For comparison, the BMW 801D radial engine that powered the FW-190 produced about 1,700 horsepower at maximum output, and that was pushing German engine technology to its absolute limits. The Americans were mass-producing engines with 20 to 30% more power and doing it with apparent ease. But it got worse, much worse. Richter examined the engine's construction for signs of shortage accommodations, the kind of compromises German factories were increasingly forced to make. Lower-grade materials, simplified manufacturing, anything to save resources. He found none. This engine was built with high-grade aluminum alloys, precision bearings, components that showed no evidence of material shortages or manufacturing shortcuts. It was built the right way, not the expedient way. One of Richter's assistants, a mechanic who had worked on German aircraft for years, pointed to the cylinders. Herr Hauptmann, look at this. Each cylinder is individually removable. If one is damaged, you can replace just that component without disassembling the entire engine. Richter nodded slowly. It was brilliant design. It meant faster repairs, less downtime, more aircraft. Operational German engines required extensive disassembly for major repairs. This American design assumed that maintenance would happen frequently and needed to be efficient. But there was something else that caught Richter's attention, something that made his stomach tighten with dread. The real secret of the P-47's performance wasn't just the engine, it was the turbo supercharger system. Richter had read intelligence reports about this, but seeing it in person was different. A complex network of ducting snaked from the engine down through the fuselage to a turbine mounted in the rear of the aircraft. The system used the engine's exhaust gases to spin a compressor at over 20,000 revolutions per minute, forcing pressurized air back into the engine. The engineering was staggering. The exhaust had to be channeled through ducting that could withstand extreme heat. The turbine had to spin at speeds that would tear apart inferior bearings. The entire system had to be precisely calibrated to avoid damaging the engine. German engineers had experimented with turbo superchargers, but they'd never successfully fielded one. The technical challenges were too great, the materials too difficult to source, the manufacturing too complex. But here it was an American fighter that was being mass-produced, not a prototype, not an experimental aircraft, a production model, one of hundreds or thousands. Richter did the calculations. With this turbo supercharger, the P-47S engine could maintain full power at altitudes where German fighters were gasping for air above 25,000 feet. The FW-190 and Bf-109 lost significant performance as their mechanical superchargers struggled in the thin air. The P-47 would be hitting its stride, fast, powerful, and completely dominant in the high-altitude realm where German fighters had to operate to intercept bombe formation. His assistant asked the obvious question, can we replicate this system? Herr Hauptmann Richter shook his head. Not with our current manufacturing capacity. This system requires precision, machining high-grade steel alloys, and thousands of man-hours of skilled labor. We're already struggling to produce enough basic aircraft. Adding this level of complexity, he paused. It's beyond our capabilities. The realization was crushing. The Americans hadn't just built a better fighter, they'd built a fighter that represented a level of industrial sophistication Germany couldn't match. After examining the engine, Richter turned his attention to the airframe itself. What he found was equally disturbing. The P-47 had taken significant battle damage. Cannon shells had torn through sections of the fuselage. Machine gun fire had riddled the wings, and yet the aircraft had flown back and made a controlled landing. Richter examined the damage patterns. Multiple 20mm cannon hits, the kind that would typically shred a German fighter. But the P-47 structure had absorbed the hits, the heavy-gauge aluminum skin, the robust internal framing. The redundant control systems all contributed to incredible durability. He pulled out damage reports from Luftwaffe units time, and again pilots reported pumping cannon fire into P-47S and watching in disbelief as the American fighters continued to fly. The reason was evident. The P-47 was built like a tank, where German fighters optimized for weight savings and agility. The P-47 was designed to absorb punishment and keep flying. The cockpit armor was extensive. Thick steel plates protected the pilot from multiple angles. The windscreen was armored glass far thicker than anything in German fighters, but most importantly, the R-2800 radial engine served as a massive shield. Unlike the liquid-cooled inline engines in the Bf-109 and FW-190, the radial had no vulnerable coolant system. You could shoot cylinders off the engine, and it would keep running. Richter found documentation showing that P-47S had returned to base with multiple cylinders destroyed, fuel tanks punctured, and control surfaces shot away. German fighters with similar damage would have fallen from the sky. One of his engineers made an observation. It's over-engineered. They've added weight for durability that could have been used for performance. Richter nodded yes, but they can't afford to. They have engines powerful enough to carry the extra weight. We have to optimize for weight because we lack the engine power to overcome it. This was a fundamental difference in design philosophy. Germany built aircraft at the edge of what was technically possible, squeezing every ounce of performance from limited resources. America built aircraft with massive safety margins, compensating for any inefficiencies with brute force. And brutally, the American approach was working better. Richter examined the P-47S armament. Next, 8 Browning M250 caliber machine guns, 4 in each wing. His heart sank as he calculated the implications. Each gun had approximately 400 rounds of ammunition. Total ammunition load, 3,200 rounds. Rate of fire for all 8 guns combined, over 100 rounds per second. The firepower was devastating. A 1-second burst would put 100 heavy slugs into a target. A 2-second burst, which was typical for a firing pass, would launch 200-round. German fighters typically carried 2 or 4 machine guns plus 1 or 2 cannon. Total firepower was less, and ammunition was more limited. A Bf-109 might have 60 rounds for its cannon, 500 for its machine guns. Once that was expended, the pilot had to return to base. The P-47 pilot could fire almost continuously for 30 seconds in practice. That meant multiple long bursts across several engagements before running out of ammunition. But it wasn't just the quantity. Richter examined the 50 caliber rounds themselves. They were heavy, high-velocity projectiles that could punch through armor and structural components with ease. Head read reports from pilots describing the effect of P-47 fire as a wall of lead. Now he understood why, with 8 guns converging at a focal point, anything caught in that cone of fire would be shredded. German aircraft, with their lightweight construction and limited armor, would disintegrate under this kind of firepower. A P-47 didn't need to be precise, it just needed to get the target generally in front of it and pull the trigger. Richter made notes recommendation: avoid head-on engagements with P-47, probability of surviving return fire minimal. As Richter compiled his technical report, he began to see a pattern that went beyond any single component. Every system on the P-47 spoke to an underlying industrial capacity that was staggering. The engine required precision machining and high-grade alloys. The turbo supercharger required advanced metallurgy and manufacturing. The airframe required massive amounts of aluminum. The armament required a functioning ammunition production industry. Any one of these components would strain German industry. The P-47 had all of them integrated into a single aircraft and was being mass-produced. Richter requested production data from intelligence sources. What he learned was soul-crushing. Republic Aviation was building P-47s at a rate that seemed impossible. By late 1943, they were producing over 500 aircraft per month. Plans called for ramping up to 600, 700, even 800 per month by 1944 for comp. Harrison German factories were struggling to produce 300 to 400 single-engine fighters per month total across all types, and German production was constantly disrupted by Allied bombing. But the numbers got worse. The R-2800 engine wasn't just used in the P-47, it powered multiple American aircraft. Total production of R-2800 engines would exceed 125,000 units during the war. Over 125,000 of these 2,000 horsepower engines. Germany's entire production of aircraft engines for all types across the entire war would be roughly 250,000 units. Most of them significantly less powerful. The Americans were building more of a single advanced engine type than Germany could produce total engines. The disparity was incomprehensible. Richter sat at his desk staring at the numbers. He ran the calculations again, thinking he must have made an error. But the numbers didn't change. American aircraft production for 1943 was projected to exceed 85,000. Aircraft German production would be about 25,000, a ratio of more than 3 to 1. But it was worse than that because American aircraft were on average heavier and more complex. A single B-17 bomber required more aluminum and man-hours than 3 Bf-109 fighters. The Americans were building thousands of B-17s. The material disparity was overwhelming. America was fighting a global war, supplying the Soviets with thousands of aircraft and tanks, equipping British forces, and still outproducing Germany in every category. Richter's final report was due to be presented to High Command in Berlin. As he compiled his findings, he knew he was writing something dangerous. The report documented the P-47's technical superiority in multiple areas. It acknowledged that Germany lacked the industrial capacity to produce equivalent systems, and it contained a conclusion that would be seen as defeatist. His summary read, "The P-47 Thunderbolt represents a level of industrial and technological sophistication that exceeds Germany's current capabilities. Its widespread deployment suggests American production capacity far exceeds previous intelligence estimates. Recommendation: tactical adjustments to minimize engagement with P-47 at high altitude. Strategic assessment: continued attrition against numerically and technically superior enemy aircraft will result in unsustainable losses. In other words, we can't beat this, and if we keep fighting the same way, we'll be destroyed." Richter's a commanding officer read the report and looked at him. Why? A mixture of respect and concern. "You know, this will not be well received in Berlin. They don't want to hear that American aircraft are superior." "Should I alter the findings?" Richter asked, already knowing the answer. "No, the report is accurate, but prepare yourself. The leadership doesn't respond well to uncomfortable truths." The report was forwarded up the chain. Richter never received an official response, but he heard through informal channels that had been dismissed as overly pessimistic. One staff officer reportedly said, "This engineer has been demoralized by enemy propaganda."